Hello everybody, it's Mr. Spinelli. Today we're going to talk about how to find the area of a trapezoid. But before I show you anything, I would like for you to pause the video and try to answer this question. Let's check your work. So I'm going to draw a diagonal, and I get to draw any diagonal I want, and it's okay if you drew a different one. And I'm going to find the area of this big triangle on the left and this other triangle on the right. So let's figure out what that would be. So remember, area of a triangle is base times height divided by 2. So that's equal to the area of a triangle. So I need to identify my height. Well, if this is my base, right, this length right here, I have to figure out what that's perpendicular to. Well, it's not perpendicular to the 15. It's not perpendicular to the diagonal I drew, but it is perpendicular to this 12. So I will do 25 inches times 12 inches and divide that result by 2. Okay, and then I'll do the same for area 2. Find its base. Well, this is the 14, and it is also perpendicular to, if I extend this line, it's also perpendicular to the 12. So that area will be 14 inches times 12 inches and divide that result by 2. Now, if I type these in my calculator, I get 150 inches squared and 84 inches squared. If I add those results together, I get the area of my trapezoid. And that will simply be 150 plus 84 is 234, and my units are inches squared. So let's take a look at how we find the area of any trapezoid we want. So if I look at this trapezoid, I can again draw a diagonal. So it's got some base lengths, base 1 and base 2. Remember, in a trapezoid, it's got two sides that are parallel to each other. And then we know nothing else about the other two sides, unless we know information about it being isosceles or something like that, or we have information about the angles and we can determine more. So these two bases are the two sides that are parallel to each other, and they're both perpendicular to this height here, h. So if I find the area of this lower trapezoid and this upper trapezoid, again I'm going to find that the area of this lower one is simply a triangle, so it's going to be base 2 times the height divided by 2. And maybe I should call this area 2 and this one area 1. You'll see why. And then area 1 would be base 1 times the height divided by 2. So if I add those two results together, I get the formula for my area of a trapezoid. It's base 1 h over 2 plus base 2 times h over 2. But that's kind of cumbersome, and what I can really do is factor out the h over 2, and I'm left with base 1 plus base 2. So the most common way you're going to see this formula written is the sum of the bases, adding them together, times the height divided by 2. Alright, so that is the area of a trapezoid. So let's put it to use. So I got to determine which two sides are parallel. Well, a key to that is noticing which sides are perpendicular to something. Well, that's the 5 and the 8. So these are going to be my bases, and this is my height. So I simply add the 5 and the 8 together, multiply that result by 4, and divide by 2. So 5 plus 4 gives me 13, and the 13 times 4 gives me 52, and if I divide that by 2, I get 26. And again, my units for area are always units squared. If I had shown my area units, or my units for length in that problem, you would have seen these units pop out. So now in the next one, I've only got two sides that are parallel to each other given, so 2.4 and 4.6. To find my area, I need to add those numbers together, multiply by the height, and divide that result by 2. Now this can be where you make calculator problems errors more than anything. So I need to type 2.4 plus 4.6 in parentheses, or I need to compute the sum and hit enter before I multiply by 3.5. Okay, when I multiply that by 3.5 and divide by 2, you should get 12.25 centimeters squared. Going with some SI units today. All right, now the next one, I don't have the height, because remember, I need to focus on the two bases, which are 20 and 25, and figure out what they're perpendicular to. Well, they're perpendicular to this right here. So I've got to do a little bit of math, and I got to do some thinking. So if I draw another perpendicular line right here, I get a triangle. But the question is, how long is this piece right here? Oops. So that piece right there is going to be this 25 minus the 20 on top. So this is actually 5 centimeters. Again, I did that by subtracting the 20 from the 25. Now when I do that, I get a special right triangle. It's one of the Pythagorean triples. It's my friend the 5, 12, 13. So my h, in this case, is 12. So then to find my area, I add the 20 and the 25 centimeters, multiply them by the height of 12, and divide that result by 2. When you do that, you should end up with 270 centimeters squared. All right, let's take a look at a few more examples. So in this one, I've got to work backwards. It says find the height given the area. So the area is 168. I'm going to write my formula. Area is base 1 plus base 2 times the height divided by 2. Let's plug in what we know. I know the area is 168. I know the bases are 9 and 19, but I don't know the height. So I got to work backwards. If I multiply both sides by 2, I get 336 equals 9 plus 19 is 28. And I get this. Okay, now if I divide both sides by 28, I get h equals 12 inches. Now some of you might work this problem a little bit differently. You could also do 168 equals 9 plus 19 is still 28, so you get 28h over 2, which then this is really 168 equals 14h. And if you divide 168 by 14, you will again get h equals 12 inches. But you've got options in how you want to solve these. So let's take a look at this very last problem that we aren't going to do until the next video. So maybe give a try on this one. This is a rhombus problem. Give that one a try for your homework and stay tuned for the next video. Thank you for watching.